It was good. Got a quick question today. Continue on with the chemical equilibria stuff. Let's speed run this, bro. I ran downstairs to get my calculator so I could make sure to do this properly. So let's get started with this. Sample of CaCO3 is placed in a 0.654 liter and pressure equilibrium constant dissociation constant of CaCO3 is 3.9. Okay, so it's dissociation, yeah. So CaCO3 solid is an equilibrium. CaCO3 or it's CaO, so CO2 then. K equals 3.9 times 10 to the negative 2. That's going to be gas, yeah. Solid. Okay, so we're putting 6.5 okay, so K, what are we trying to find? We're trying to find the mass of this, so we need moles of that. How do you find moles? We know pressure. Okay, equilibrium. Okay, wait, now I'm looking confused. Solid. Okay, so K products over reactants, but this is solid. This is also solid. So that's going to be equal to CO2 is going to be equal to 3.9 times 10 to the negative 2. That means the partial pressure of CO2 must be 3.9 times 10 to the negative 2 because the solids are not appearing. Okay, that makes sense. So now what? What units is 3.9 times 10 to the negative 2? And that's pressure. PCO2. Okay, but what do we do with that? Okay, so we have P. What else do we do then? Do we use gas law? PV equals nRT. We have volume. PV and we have R. Okay, we have T. So I guess we can find the moles. Okay, so we'll use PV equals nRT. N equals PV over RT. And we know pressure, so this is going to be CO2. Pressure 3.9 times 10 to the negative 2 multiplied by volume 0.654 divided by this ATM. Wait, hold on. Wait, what units is this? 3.9 times 10 to the negative 2? It doesn't even say what pressure it is. What's the units for it? Do we just assume ATM? I guess so. 0.08206 liter ATM over mole times Kelvin multiplied by temperature, which is 1000 Kelvin. Okay, put that into the calculator. 3.9 E negative 2 multiplied by 0.654 divided by 0.0. 3.1 times 10 to the negative 4. And this is going to be moles of CO2. Now we got to relate them. So we got moles 3.1 times 10 to the negative 4. And it's a 1-to-1 ratio. So that means these two are going to be equal to each other. So that means moles of CaO equals 3.1 times 10 to the negative 4 moles. So now we need to find the mass, yeah, so mass. What's the molar mass of CaO? Why am I even writing all this? 0.017 grams. There you go. Question 1 done. We're only doing 2 questions today. It's too late. Spent too much time with the phone. Okay, this is going to take a long time. This one's like a complicated one. So this one is a large K. Large K. Large K. What do we do? What do we do? Well, this is what's going to happen. So say we have equilibrium right here, right? So the reaction is going to happen. And it's going to go to completion. But it's going to go a little bit forward because K is big. And now that'll be like 1. And that's like part 1. And then it's going to go back to equilibrium. That's going to be part 2. So we got to do 2 ice tables for this. One in forward, one is reverse. So I guess we'll just start. Let's write down this reaction. No gas plus O3 NO2 plus O2. Gas, gas, gas. What is the units? ATM. The Don Toliver song. Ice. But when I was doing these questions, like in school, this was like when the whole ice controversy was happening. I guess that's how I remember things. Okay, anyways, calculate the position of equilibrium with 0.28 atm of nitric oxide. Okay, so this reaction is going to go to completion. So what's the limiting reagent? Well, which one has less moles? Nitric oxide. So this is the new kind of initial. So this is like, this is where we're at right now. So now we need to go backwards. So we're going to go to the reverse reaction now. Just bring these 2 here. I'm not going to write all that. So we're going to start with what are we going to start with? 0, 0 0.30, 0 0.28, 0 0.28. Now we're going to be going this way, plus x minus x minus x. And now in this case we're not going all the way to completion, so we need to find out what the value of x is. And we're going to do that by substituting into the k. It's just 2, 0.28 minus x. Okay, so now k, this is the reverse. But what I'm going to do is, instead of finding the inverse of k, I'm just going to put these as they are, like products of reactants. So I'll just put this and this, even though it's backwards, because I'm not going to be flipping k. I think yesterday I made a statement about like how it won't work because k is small and we can't make the assumption. Well, it turns out we can, because we know that the reaction is occurring in reverse. So that means small k reverse, therefore assumptions. 0.28 squared over x times 0.30 is equal to 1.32 times 10 to the 10. Okay, let's just put it into our calculator. Let me just see if I get this right, otherwise then we have to do the other part. But I'm like 99% sure that works, bro. Like, I'm like 99% sure. Like 99.999. Yeah, that works. 1.98 times 10 to the negative 11 ATM. What are we even trying to find? Position of equilibrium. Well, what specifically do you mean by that? The position of equilibrium. Like what each thing is at equilibrium? What are we trying to find? Reaction quotient? No, we're not. Okay, I don't know. Okay, so we're just gonna state each one. So NO is at bro, I don't want to add these, bro. Plus 0.3 equals 0.3. 0.28 minus this, like not like the small numbers. So it's going to be like the same number. So yeah, that is our answer. Oh wait, we need to check assumptions. So I always forget that. Like realistically, what are we going to do if these assumptions don't work? Nothing. What? Like what? Yo, these are like negative like negative 10 yeah, bro, these are right, bro. There's no way these are not right. Yeah, they're valid. Okay, that's pretty much all for today. I'll see you tomorrow.